Okay guys, this is 17.1, problem solving with trigonometry, day 2. So this is a continuation of what we did in class on day 1. Okay, so first I want to start with the area formula, which is what we did at the very end of class, but we didn't actually get through the entire thing. Okay, so real quick I'll explain what the formula looks like, and then I'll tell you guys the easy way to remember how to use the formula. Okay, the area formula tells you how to find the area, hence the name, area formula, of a triangle, and it doesn't have to be a right triangle, for which you don't know the height. Okay, so if you guys look at this triangle right here, triangle ABC, we don't know the height of this triangle at all, right? The height is a vertical line that goes from the highest point straight down, right, perpendicular. So if you don't know the height of a triangle, then the area formula tells you exactly what you need. And there are three ways to write it: this one, and this one. And they're all the same thing, okay? What it basically means is that if you know two sides, let's say I know side A and side B, and the angle between the two sides, see, A and B, these are the two sides, and the angle C, if I know that information, then I can find the area simply by multiplying A times B, see that right here, A times B, finding the sine of the angle between them, sine of C, and then multiplying times 1/2, right? That's very familiar to the formula for the area of a triangle, which is 1/2 base times height. Let's say I know A and C, then the formula is A times C times the sine of B times 1/2, which is this one right here. What if I don't know A and C, or A and B? What if I know B and C? If they gave me B and C, then the formula is B times C times the sine of A times 1/2, right? So it's always two sides and the angle between them, the angle that is included by them. So we're going to be using that formula a lot in the examples that I'm going to give you guys. It's actually a very simple formula to use. Okay. The other thing we're going to be doing in this is using all of these useful formulas and facts to solve triangles, meaning find all the missing sides and all the missing angle measures for the triangles. Pythagorean theorem is something that you guys should know, and you should know very well. If you know two sides of a triangle and you're trying to find the third side, then you use the Pythagorean theorem. We're also going to be using the trigonometric ratios, sine, cosine, and tangent, which you should be familiar with from integrated 2, but again, like yesterday, we're going to be using them to get you guys back into the idea of using all these ratios, okay? You can remember these three by the SOHCAHTOA, right? Remember, everybody knows SOHCAHTOA, which you must know how to spell correctly if you're going to be using this. So, S-O-H, Ka, C-A-H, TOA, T-O-A, which stands for the sine, S, is opposite divided by hypotenuse, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, those are the three trigonometric ratios. Okay, so sine of an angle, here the Greek letter theta means is an angle. Okay, we always use the Greek letter theta to represent an angle. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. Tangent of theta equals opposite over, hey, that is wrong, let's fix that. What's the mistake here? So fix that on your notes, please. Opposite over adjacent, not hypotenuse. Change that H to an A. There. Opposite over adjacent. There you go. Now they're correct. In addition to that, we're going to be using the distance formula, something else that you have seen before, but you probably haven't used in a while. We introduced this to you back in integrated 1. Maybe you saw it as well in integrated 2. This allows us to find the distance between any 2 points as long as I know their coordinates, right? x2, x1 are the x coordinates of the 2 points, and y sub 2, y sub 1 are the y coordinates of the 2 points. We plug them into this formula, and then we can find the distance. Another useful fact that you need to know is that perpendicular lines always form right angles. How is this important? Because we're going to need some right triangles eventually, like this one down here. So if we know that there's a right angle, then we know that we have a right triangle. Also, perpendicular lines have slopes that are opposite reciprocals of each other, right? That is something that you learned back in integrated 1, but we're going to really quickly mention that again in one of the problems, so I need you guys to know this as well. Opposite lines have opposite reciprocals of each other. And what does that mean? Let me just give you a quick example. If a line has a slope of, let's say, 2/3, then the perpendicular slope, or the perpendicular, the slope of a perpendicular line to that one is going to be -3/2. So opposite, positive, negative, reciprocal, 2/3, 3/2. All right, then let's start with number 1. It says find the area of the triangle to the nearest tenth. So what I see, what you should notice is that they give you two sides, right? 3.2 and 4.7, and they give you the angle right between the two sides, the angle that is included by the two sides. So this is perfectly set up for the area formula, okay? So let's write the area formula again. You have it right there on your notes, right above. The area of a triangle is given by A times B. Whoops, let's erase that. Let's put the 1/2 first, okay? Oh, you know what? Let's just write it like this. I'm used to writing it like this. AB sine of C divided by 2, which is the same thing as it is written up there in your notes, right? A times B times sine of C divided by 2, okay? Which means two sides, A and B, the sine of the angle between them, angle C, and then divide everything by 2, which is the same thing as multiplying times 1/2. So then if I plug in my numbers here, in this case, A would be 3.2, B would be 4.7. That's not going to fit there, so I'm going to move all of this work over to this side. Okay, so I moved it over to the left side over here so it would fit. 3.2 times 4.7 times sine of 142, all divided by 2. At this point, it's just calculator work, okay? What you got to just make sure is that your calculator is in degree mode, not in radians mode, okay? So if you have a scientific calculator with you, then just double check that your mode is degrees, not radians. Also in the graphing calculators, you got to make sure you go to mode and change it to degrees in case it's in radians, okay? So once you plug this in, according to my calculator, it says 4.63, but it says round to the nearest tenth, so 4.6 meters squared. Done. Okay, I'm going to show you one more, and then 3 and 4 are going to be for you guys to do on your own, okay? So here we go, number 3. There's a triangle called DEF where DE is 9, DF is 13, and the measure of angle, what's missing here? D. It's missing a letter here, guys. It should say angle D. That's the one missing there. Okay. So in order to see this better, I'm going to go ahead and draw a triangle. Any triangle, doesn't matter what kind of shape you draw. Label it D, E, F. And then put in the values that they gave us, right? DE is 9 inches. Here's DE. That's 9 inches. Also, DF is 13. Here's DF. That's 13. And angle D is 57 degrees. So there you go. That fits perfectly with our area formula, right? The area is A times B times sine of C all over 2, which really just means two sides, the sine of the angle between them included by them divided by 2, right? So let's plug in the values that we have here, and we're going to get A equals 9 times 13 times sine of 57 divided by 2. And once again, at that point, it's just punch into the calculator. So my calculator says that this is approximately 49.1. Again, rounding to the nearest tenth. It says 49.0622, but rounding to the nearest tenth. 49.1, what are these? Inches? We're looking for the area here, so you need to put the units. Inches squared, or square inches. Alright, number 3 and number 4 are for you guys to try out on your own, okay? So go ahead and try them on your own. Pause the video right now so that you guys can try them, and then come back once you guys are done. It should take you about I don't know, 4 minutes total, maybe even less. They're actually pretty simple, maybe 3 minutes total, okay? So go ahead and pause the video right now, try them on your own, and then come back to check your answers. Okay, so here you go. These are the correct answers for number 3 and number 4. For A, I set it up this way, 12 times 15 times sine of 34 over 2, which gave me approximately 50.3 millimeters squared for the area. For number 4, I set it up this way, 3 times 6 times sine of 108 divided by 2, and I got approximately 8.6 centimeters squared for the area. Notice that for all these formulas, it's always sine. So you guys aren't wondering, am I supposed to use sine, cosine? Because a lot of the problems that we solved yesterday, you had to use different trig ratios, right? For the area of the triangles, using the area formula, it's always going to be sine, every single time. Alright, let's move on to number 5. This is one of the fun ones. We're going to do a lot of work on this one right here. A shelf extends perpendicularly 7 inches from a wall. Okay, so here's the shelf, here's the wall. So here's the shelf sticking out of the wall. You want to place a 9-inch brace under the shelf. So there's a 9-inch brace that you're going to place right here under the shelf to hold it up. To the nearest tenth of an inch, how far below the shelf will the brace be attached to the wall? To the nearest degree, what angle will the brace make with the shelf and with the wall? Okay, so how far below the shelf will the brace be attached to the wall? That means this distance right here. What is this distance? Here's the shelf. How far below will it be attached? And then this other question, to the nearest degree, what angle will the brace make with the shelf and with the wall? So what's this angle that the brace makes with the shelf? And what is this angle that the brace makes with the wall? So we're looking for this angle, and this side. Okay? I'm going to label the missing side and call it little a. And the reason for that is because this is angle A, right? There's an ABC triangle right here. This is angle A, and the usual convention for naming the sides is that the side opposite of that one is little a, lowercase a. Where if this is angle B, then this is side B, right? Little b. I don't have to name it because I already know what it is. It's 7, right? And the other one over here, this one would be C because this is angle C, so this will be side C, okay? So that's the only one that's missing, and I'm also missing angle A and angle B. Those are the questions. What are angle A, angle B, and side C? So we can start with either one. I'm going to start by finding A, the side, okay? I know 2 sides, and I'm missing 1 side. Every time you have that, then it's easy to find the third side by using the Pythagorean theorem, okay? I know 2 sides, I'm missing 1, so what we're going to use is a squared plus b squared equals c squared. The Pythagorean theorem, which says that if you know 2 sides, then you can find the third side of a right triangle in this way. So a squared, we don't know what a is, so we're just going to leave it as a squared. B squared, in this case b, is 7, right here. So 7 squared equals c squared. C is always the hypotenuse, so that's 9. So a squared plus 49 equals 81. Subtract 49 from both sides. So a squared equals 81 minus 49, 32. Let me double check that, just make sure I'm not making some dumb mistakes here. No, that's good. Take the square root of both sides to solve it, to finish it. Square root of that one, square root of that one. Squaring and square rooting cancel each other out. So my answer is whatever the square root of 32 is. Calculator time. My calculator says 5.656 and so on. It does say here to the nearest tenth of an inch, so that means 1 decimal place. So I'm going to leave it as 5.65. That means 5.7 inches. So right here is 5.7 inches. I'm going to put that there. Inches. Okay, so make sure you get this work because I'm going to erase it so I could use the same space to find angle A and angle B. Okay, so go ahead and make sure and have this because I'm about to erase it. All right, to find the measure of angle A and angle B, we're going to need to use some of the trig ratios, okay? So when you're using the trig ratios, you have to make sure you focus on one of the angles, okay? Not the right angle, but the other two angles. Focus on one of them, and it doesn't really matter which one you choose to focus on. I'm focusing today on this one, on A. But I could just as easily choose to focus on B, and it will still work out. But I'm going to focus on A. If you focus on A, then the side that is next to it, well, first of all, this is the hypotenuse always, regardless of which angle you're focusing on. The longer side, the one opposite the right angle, is always the hypotenuse. So let's label that one H for hypotenuse. Then the side that is next to it, that's not the hypotenuse, that one is called adjacent, right? It's right next to it, so it's called adjacent. We're going to label that one adjacent. And the side that is across from the angle you're focusing on is the opposite side. Let's label that one opposite. Okay? And this is where the trig ratios come in. So I'm going to write SOHCAHTOA again. SOHCAHTOA. Which means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay? So we're trying to figure out what angle A is. We don't know what angle A is, okay? But we do know the adjacent side, we know the hypotenuse, and we also know the opposite side now that we found it. I really don't want to use this one in my calculations because it is an approximation. So I want to use these two. So that means I need to use the adjacent side and the hypotenuse. If you look at your trig ratios here, which one includes adjacent and hypotenuse? And you should say cosine, right? Cosine is equal to adjacent over hypotenuse. So that's what we're going to use because that's what I have as the information. Could you also use the opposite side? Yes, you could. I'm just choosing not to use it because it is an approximation. So let's go with the cosine. According to the trig ratios, cosine of angle A, I don't know what angle A is, so I just put angle A right there. Cosine of angle A is equal to adjacent over hypotenuse, right? So what is the adjacent side? 7. And the hypotenuse? 9. So cosine of A is equal to 7 over 9. And now what you need to do is use the inverse cosine to find what A is. You cannot, I'm going to keep repeating this so you guys never make this mistake again. You cannot just say, you know what, I'm going to divide by cosine to get rid of it. It doesn't work that way. You can't divide by an operation, okay? So what you're going to do instead is take the inverse cosine of both sides, which will cancel the cosine. It looks like this. Inverse cosine of cosine of A equals inverse cosine of 7 over 9. And why do we do that? Because inverse cosine and cosine cancel each other out. They're inverse operations. They just both go away, leaving you with just A. And then on the right side, inverse cosine of 7 over 9, you punch that into a calculator. You should be able to find the inverse cosine symbol on your calculator. So just punch in inverse cosine 7 over 9 and see what you get. As I said before you make that calculation, make sure your calculator is in degree mode, okay? According to my calculator, it says 38.94. It says to the nearest degree, right? So that just rounded up to 39. 39 degrees for angle A. So we got angle A. We got the measure of the side. So we answered 2 of the questions, right? But we do also need to find what's the other angle. What is the angle that the brace makes with the wall? So to find this angle, it's much easier now. If you know this one is 90 and this one is 39, you know that all 3 angles in a triangle should add up to 180. So all you got to do is just add those and subtract from 180, right? It looks like this. If you want to put it in actual algebra on your paper. 90, which is the right angle here, plus this one, which is 39, plus whatever angle B is, the measure of angle B, equals 180. 90 and 39 make 129. plus the measure of angle B is 180, and then just subtract from 180 on both sides. Subtract 129 on both sides, and you're going to get 51 degrees. And there you go. You found them all. Alright, I'm going to let you guys fight with and struggle with number 6 for a little while. Okay, so go ahead and try it on your own. Make sure you read the question carefully, but if in case you don't understand what it's asking you for, just find every single missing side and every single missing angle of the triangle. Remember, we're focusing on the triangle. The building is really not that important right now. The triangle, you're looking for this angle, oh no, wait, they gave you that angle, okay? This side, which is the height here, and then this height right here, this distance right here. So you're looking for every single missing distance. Okay, so go for it. Pause the video. Try it on your own. It's gonna take you a while. This is gonna take you a little bit of work. So it should be like 5 or 6 minutes at this point to try this one problem. Go for it on your own though. Don't give up, and come back and see the correct answer. Okay, so here's all my work and the answers that I got. I started first by choosing an angle to focus on. I chose this one, F, which I know that is 27 degrees. You could have chosen D as well, but I chose F, okay? Since I chose F, then what I went ahead and I did is I labeled the sides based on their relationship to F. So here's F, so this side is the opposite, this side is adjacent, and this side is the hypotenuse, right? I also labeled each side with a letter or a variable that I would use to solve for it. So this is side E and this is side D, okay? Now looking back, we didn't really need to find the measure of side E. I went ahead and did it to solve the full triangle, but it's not one of the questions here, right? The question is how tall is the building, which is D, and what's the angle that the ray from the sun along the edge of the shadow makes with the ground? So I need to figure out this angle right here. So we really did not need to find D, although I did go ahead and did it, okay? So first, I started by finding the measure of angle D. That was easy because this is 90, this is 27. All three angles in a triangle add up to 180, so the measure of angle D plus 27 plus 90 equals 180, and then I solved and I got 63. Then what I did after that is to find E, which again, we didn't really have to. It's not one of the questions. But to find side E right here, I used the sine of this angle, sine of F, which is 27. According to the trig ratios, the sine is opposite over hypotenuse, right? So the sine of 27 is opposite, 33, over hypotenuse E. So 33 over E. I multiplied both sides by E, so it canceled here and it came over here. And then I divided by sine of 27, so I got this. I just punched this into the calculator and I got approximately 73 meters for E. And I did the same thing to find D, but except I didn't use sine, I used tangent. And the reason I use tangent is because if I'm looking for D, that's the adjacent side. And I know the opposite side, opposite, adjacent, the only thing I can use there is tangent. So tangent of 27 is opposite, 33, over adjacent, D. 33 over D, multiply both sides by D, divide by tangent of 27. So this is what I punched into the calculator, and I got back 65 meters. Okay, so the last two problems, 7 and 8. I'll do 7, you guys will do 8, okay? So here we go, number 7. Triangle ABC has vertices A, which is negative 3, 3. It's right here, negative 3, 3. B, negative 3, negative 1, right here. C, 4, negative 1, right here. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So what are the lengths of the sides is the question, and what are the angle measures as well. Okay, let's start with the sides because they seem to be pretty simple. Side AB, you can do by just counting squares. Okay, since this is positive 3 and this is negative 1, you could just count them and it's going to be the correct answer. Okay, 1, 2, 3, 4. That is 4. Let's put that there already. That was easy. Side BC, same thing. And by the way, this is only easy because it's a vertical line and a horizontal line, right? You can't just count squares on a diagonal line. So side BC is going to be 1, 2, 3, 4, 5, 6, 7. Just 7. 7. Side AC, not so easy, okay? So at that point, to find side AC, you could go back to your notes and use the distance formula, or you could simply use the Pythagorean theorem, right? a squared plus b squared equals c squared, and that should also give you the correct answer. Okay, so either distance formula using point A and point C, because you're trying to find the distance from A to C. So using these 2 points into the distance formula, or use the Pythagorean theorem, 4 squared plus 7 squared equals this distance squared. So let's use that. 4 squared plus 7 squared equals, I haven't assigned a variable to that distance. I'm going to call it side B. Why? Because it's across from this angle B, right? Angle B, side B, right there. So B squared. That's 16 plus 49. And 16 and 49 are going to be 65. And then take the square root of both sides to get B by itself. Okay, so radical 65, punch that into your calculator. So the calculator says 8.06225 and so on. It says here to round to the nearest hundredth, so that's 2 decimal places, right? So I'm going to leave it as 8.06. There you go. We found that side, 8.06. Right here. Okay, let's go ahead and move on to the angles now. So to find the missing angles, first of all, angle B is easy, right? A vertical line and a horizontal line, that's a 90-degree angle for sure. So let's put that there. That's 90. Let's fix that. There you go. 90-degree angle right there. Angle A and angle C, those are the tough ones, okay? In order to solve for them, you need to focus on an angle. As soon as you start thinking, I need to use some trig ratio, sine, cosine, tangent, you need to focus on one of the two angles. It doesn't really matter which one. Just choose one to focus on. We're going to focus on angle C here. Why not? So if I'm focusing on angle C, I have, okay, I'm going to label the sides as they relate to angle C. The side across from it is opposite. So this one's opposite. The side next to it is adjacent. And the longest side is always the hypotenuse. So I need to find the measure of angle C. So I have the option of using sine, cosine, or tangent. The reason why you have an option is because you know all three sides. You know that's 4, you know that's 7, you know that's 8.06. Although, again, this is an approximation, so I prefer not to use the values that I found. I prefer to use the values that are pretty easy and clear to use. So I'm going to use the opposite, which is 4, and the adjacent, which is 7. Which trig ratio do I need then if I'm looking at the opposite and the adjacent? Tangent, right? Look through SOHCAHTOA. Which one has an O and an A in it? That's tangent. So we're going to write tangent of C, tangent of angle C, is equal to opposite over adjacent, 4 over 7. And we need to solve for C. How do you isolate the C here? Remember, don't divide by tangent. That doesn't make any sense. You need to find the inverse, right? You need to cancel tangent. To cancel tangent, you need to take the inverse tangent of both sides. So you take the inverse tangent of both sides. Inverse tangent of this one as well. 4 over 7 right there. So that's what I did. All I did was take the inverse tangent of both sides, because what happens? Inverse tangent and tangent cancel out, leaving you just with C. And on the other side, you just have the inverse tangent of 4 over 7, and you punch that into a calculator. So punching that into a calculator, it says 29.74 degrees. It says to the nearest degree, so let's round it up to 30. 30 degrees. 29.7 rounded up to 30 degrees. And knowing that that is 30, if this is 30 and this is 90, then you should find the other one very easily, right? All three angles in a triangle always add up to 180. So 30 plus 90 plus the missing angle here is 180. You could even do that with mental math, but this is basically what you're doing. You're saying 90 plus 30 plus angle A, the measure of angle A, equals 180. That's 120 plus the measure of angle A equals 180. And that means that the measure of angle A is 60. So that's 60 degrees right there. And this one's 30 degrees. And there, we found every single missing side and angle. Alright, I'm going to let you guys work on number 8 on your own. I'm going to go ahead and get you started though, just to show you guys what it is that you need to do. Okay, so it says triangle DEF has vertices -4, 3, 3, 4, and F0, 0. So they didn't draw it for you like on number 7. So let's draw it ourselves. -4, 3 is right here. That's D. 3, 4 is right there. That is E. And 0, 0 on the origin, that's F. So there's this triangle right here. That's what you're looking at. Like that. And that is a right triangle with a right angle here. Although that's not obvious at first glance. The reason why I know that it's a right triangle is because the slope of this line, right? Remember how to find the slope by just counting squares? From here to here, you go up 4 over 3. The slope there is 4 over 3. 4 over 3. And the slope of this line, right, if you look at this one as it goes down towards this one, it's down 3 over 4, is -3 over 4. So look at those two slopes. They're opposites of each other and reciprocals of each other, which tells me that these two lines are perpendicular. Right, perpendicular lines have opposite reciprocal slopes, which tells me that this is a right angle. So that's how I know that that is at a right angle. All right, and then after that, what you're going to do is find the distances of the sides, right? You're going to need this distance, and this distance. What I suggest you guys do is find this one, and then use those two in the Pythagorean theorem to find the third one, okay? But how are you going to find this distance? This is where the distance formula comes in from your notes. So look back at your notes and use the distance formula. I'm going to do one of them for you, and then everything else will be on your own, okay? So let's find DF. The distance DF. Then this is something that you guys did back in integrated 1 and integrated 2 as well, okay? So using the distance formula. It looks like this. That's a minus sign inside the parentheses, a plus sign between the parentheses, and they're both squared. And what goes in those places is right here you put both x values, and right here you put both y values. Or vice versa, you could put the y's first and the x's first, just don't mix and match. Since I'm looking at DF, the x values are -4 and 0, right? DF. So -4 and 0 go here. -4, 0. And then the y values go here, again DF, that's 3, 0. And just simplify that. -4 minus 0 is -4. Square it, and that's 16. 3 minus 0 is 3. Square it, and that's 9. Take the square root of both sides. 16 and 9, the whole thing. 16 and 9 make 25. Then take the square root, and so that's 5, right? Exactly 5. This side is 5. All right, so I'm going to let you guys continue from there. You guys do it from this point. Find this distance using the exact same thing I just did. Then using this distance and that one, since you already found it, use the Pythagorean theorem, right? A squared plus b squared to find this other distance. Or you could also find it using the distance formula again, right? And then after that, find all the angles. You already know that one's 90. That one and that one, you're going to have to use either sine, cosine, or tangent, and you have to use the inverse to solve for it, okay? So go for it. Try it on your own, struggle with it for a little while, and then come back and check your answer. Should take you about 5 to 6 minutes. This is a long problem. All right, here you go. I found all of the solutions. So this is my work and my solutions. I started by looking for FE, right? The same way that I did for DF, FE right here. I used the points 0, 0, and 3, 4. Plugged it into the distance formula, and it looks like this. I got 9 plus 16, which is 25. Radical 25 is 5. So it ends up that FE and FD are the exact same size, okay? Then what I did is I used the Pythagorean theorem to find DE. 5 squared plus 5 squared equals, I call this side F because this is capital F, so that's lowercase f, equals F squared. That means 25 plus 25, so 50, square root of 50, I got 7.07 for F. Okay, so that's that side right there. Now that I had 3 sides, it was time to focus on the angles, so I could find the angles. I chose this one to focus on, okay, which means that once you choose that one to focus on, this is called the opposite, this is called the adjacent, and this is called the hypotenuse, right? And so using that, I started first by using the tangent of angle E, because tangent is opposite over adjacent, so that's 5 over 5. Tangent of E equals 5 over 5, which is 1, that's why I have a 1 here. In order to solve for the measure of angle E, I had to take the inverse tangent, right? Inverse tangent and tangent would cancel, so the measure of angle E is 45. According to my calculator, inverse tangent of 1 is 45. Once I found that this one's 45, then I know 90 plus 45 plus angle D equals 180, so the only thing left for that one is 45 as well. Okay? There was another way to find the angles. Once you saw that this side is 5, this side is 5, and this is a right triangle, you could have used the properties of this is an isosceles triangle, right? 2 equal sides, to figure out that these two angles have to be 45. Because this is 90, and these two have to be equal to each other since these two sides are equal to each other. So the only way they could be equal to each other and add up to 90 is if they're both 45 degrees. Okay? But I went ahead and used trigonometric ratios, which is what we're practicing right now. Alright, we're done here. You guys can go ahead and start on your homework, which is right here on the right side. There's only 6 problems, but all of them are fairly challenging. You have to find a lot of stuff about each problem right there. Okay, so go ahead, get started on it. Good luck. See you guys tomorrow.